Please enter your attendance. Okay, we'll start our class. So today I'll be talking about this polar coordinate system and curvilinear coordinate system. It'll be kind of introduction to curvilinear coordinate system. We'll see how far we can cover in curvilinear system. And again, I would like to take one extra class tonight at 8 p.m. so that there will be a continuity in our lecture. If we have one lecture in a week, then it's a big problem for me. And also probably for you also, there will be a sort of long gap between each lecture. And if we are in the middle of something, then if we continue after 1 week, I don't think you will be able to catch up. And for me also, it would take time to recap whatever we discuss. So so let us discuss this topic. I think everybody knows what is this plane polar coordinate system. Actually, wait a minute. I need one blank space. Yeah, here it is. In any space or in a 2D space, let us talk about 2D space, because plane polar coordinate system is in 2D system. Plane polar is also 2D. Plane polar system is 2D. Right. So let's say we have a 2D space. In a 2D space, if we take this 2D Cartesian system, this is a two-dimensional Cartesian system, x, y. XY is a 2D Cartesian system. Okay. Here we have a x-axis and y-axis, which are at 90 degrees. And using this 2D Cartesian system, we can define any point in this two-dimensional plane. Like, for example, we can identify this point. How do we identify this point? In order to identify this point using this 2D Cartesian system, we are going to do it like this. We're going to draw a perpendicular on this x-axis, and we will see where it intersects the x-axis. And from there, we will measure the x-coordinate value. The x-coordinate value, right? And also we draw a perpendicular on the y-axis, and from here we measure the y-coordinate value. So once we know the x-coordinate and the y-coordinate value in this 2D Cartesian system, we can identify the location of the point, or the point is known to us, right? So there's another approach of coordinate system, another coordinate system in a 2D space. That coordinate system in a 2D space is what we are going to learn it as the plane polar system. Okay, plane polar coordinate system. Plane polar coordinate system. So here in plane polar coordinate system, instead of using xy coordinates, we are going to use r theta coordinates. Okay, r theta coordinates. So just like we can identify the location of the point using x coordinate value and the y coordinate value, we can identify the location of this point using the r coordinate and the theta coordinate value. So what is r coordinate? R coordinate is simply the distance of the point from your origin. R coordinate is simply the distance of the point from your origin. So this length or this distance is your r coordinate value. And what is your theta coordinate value? Theta coordinate value is the angle subtended with this x-axis. This is your theta coordinate, right? So now if you look at this point, If you know the distance from the the origin r, and if you know the angle subtended here theta, then you will be able to identify this point. So for a specific value of r and theta, there will be a certain specific point in this two-dimensional space. So I hope you can agree that uh, rather than using xy coordinate system, we can also use r theta coordinate system. Once r and theta are known to us, then we know the point. We know where the point is located. All right. So that is called your r plane polar system. And here from the picture here, I think you can see that uh, the relation between the plane polar coordinates and the Cartesian uh, plane Cartesian system, 2D Cartesian system. The 2D Cartesian system, you have x, y, right? So if you look at this, or let me go back. If you look at this is the angle here. What is the x and r relation? If you take cosine theta here, this will be adjacent upon hypotenuse r. So x is going to be r sine theta. Now, this is y, means this height is also y here. So if you take your sine theta, then it will be y upon r. And from here, you can write y as r sine theta. As you can see here, x can be written as a function of r and theta. That is, x can be written as a function of r and theta. And here also y, as you see, y is written as r sine theta. So y is simply a function of r and theta. Y is a function of r and theta. All right. So you have two coordinate system. When you are writing the relation of the coordinate variables to another coordinate variables, that relation between the coordinate variables are known as transformation relations. We call that a transformation relations. We have xy coordinate system. When we write x and y in terms of r and theta, that is called transformation relation between two coordinates. Transformation relations. Okay, transformation relations between two coordinates. Now you can also write a reverse transformation. That means you can write r and theta in terms of x and y. So what is r here? If you use this right angle triangle and Pythagoras theorem, your Pythagoras theorem will be r square is equal to what is that? X square plus y square, isn't it? Just like this. R is going to be, you are using your Pythagoras theorem, x square plus y square. So r can be written as square root of x square plus y square. So what does that mean? This means that r can also be expressed as a function of x and y. As you see, r is written as a square root of x and y, x square and y square, right? And similar to that, if you take the ratio here, y upon x will be r, sorry, this is cos theta, here it is sin theta. There was a mistake, this is cos theta, r sin theta upon r cos theta. This and this cancels out, so tan theta is equal to y upon x, and from here you can write theta as tan inverse of y upon x, or theta, as you can see, is tan inverse of y upon x, means theta is a function of x and y. So we can have two sets of relations like this. X, we can write it as a function of r and theta. Y, we can write it as a function of r and theta. And this relation, if we call it transformation relations, okay. And similar to that, we can transform the r and theta coordinates to x and y coordinates using this relation. This is called reverse transformation relation. Okay, reverse transformation relation. Right. Now, Let us look at this example. So in the 2D Cartesian system, unit vectors along the coordinate axis, you know it, they are I and j, right? They are I and j. Here unit vector along x-axis is your I, unit vector along your y-axis is your j cap, right? So you can also obtain it like this. This is simple. Position vector in a plane Cartesian system is this. In a 3D Cartesian system, position vector, we express it very often. In a 3D system, position vector is like this, yj plus zk. So if this is a 2D system, this is xi plus yj, right? So tangent vector, I think when I discuss differentiation, differentiation gives you a tangent. So when you write like something like this, suppose this is y, suppose this is x, or suppose this is certain function. So if you take a differentiation of df upon dx at any point here, at any point here, we are taking increment along x del x. We are taking changes along y del f, along this axis del f, but we are taking this differentiation under the condition that limit del x tending to 0, so del f del upon del x. So when we do that, del f upon df upon dx will simply give you a tangent at this particular point on the curve, right? So tangent, like if you know the position vector, tangent vector along x coordinate, you can obtain it by differentiating with the x variable. So when you differentiate with the x variable, tangent vector is I, right? Unit vector is simply the vector, tangent vector divided by the magnitude. The magnitude of this is 1, so this is I. Similar to that, we can also do, we can also find unit vectors in plane polar coordinate system. So position vector in plane polar coordinate system, you can express it like this. I hope there's no problem, because if you remember, in a 3D Cartesian system, 2D Cartesian system, this is the position vector over here in a 2D Cartesian system. So simply put x as r cos theta, y as r sin theta, then you get a position vector in plane polar system. This is a position vector in plane polar system. Tangent vector along r coordinate line, you can obtain it by differentiating the position vector with respect to r. So differentiate the position vector with respect to r. What you're going to get, differentiation of r with respect to r is 1. Differentiation of r with respect to r is 1. So the remaining is cos theta I plus sin theta j. So this gives you the tangent vector along the r coordinates. So unit vector along the r coordinate line, you can obtain it. Unit vector, here you put a cap sign here for the unit vector. Unit vector is when you divide the vector with the magnitude. So divide this vector with the magnitude, then you will get tangent unit vector. So tangent unit vector is, this is the vector divided by the magnitude. Magnitude is square root of this. Cos square theta plus sin square theta is 1. So this is your unit vector along the r coordinate line. And similar to that, you can find tangent vector along the theta coordinate line. How do you find tangent vector along the theta coordinate line? Use the same logic here. To find a tangent vector, you simply divide the position vector with the coordinate variable. You get the tangent vector and then the corresponding unit vector, right? So here also, you know that to find a tangent vector along the r coordinate line, we simply divide the position vector, we simply differentiate the position vector with one of the coordinate variable, that is the r coordinate variable. Then we get the tangent vector, and then you can find a unit vector like this. Similar to that, if we are going to find the tangent vector along the theta coordinate, we simply have to differentiate the position vector with respect to the theta coordinate variable. So when you do that, differentiation of cosine theta is minus sine theta. So r is still there. So r minus r sine theta I. Differentiation of sine theta is cosine theta. So this is plus r cos theta j. Then in order to obtain the unit vector along such tangent vector, that is along the theta coordinate, you differentiate the vector with the magnitude. Then if you do that, here it's going to be like let me expand it. It's going to be like minus of r sine theta I plus r cos theta j divided by square root of this is minus of r sine theta square plus r cos theta square. So if you do that, minus of r sine theta I plus r cos theta j divided by this is going to be minus square is 1. This is r square sine square theta r square cos square theta. So if you do that, denominator you can take r as a common factor r. This is sine square theta plus cos square theta. So numerator is there. Sine square theta plus cos square theta is 1. Right. So this is minus of r sine theta I plus r cos theta j. So r and r will cancel out. Then what you are going to get is minus of sine theta I plus cos theta j. Okay, this is what we are going to get as a unit vector along the theta coordinates. Now, you know that this 2D Cartesian system is orthogonal. Orthogonal in the sense, here you have I vector, here you have a j vector. Unit vector along one coordinate exists, that is I cap. Unit vector along another coordinate exists, that is j cap. They are at 90 degree. How do you know that I and j cap are 90 degree? Because I dot j is 0, right? I dot j is 0. Angle between them is 90 degree. We can prove that. Unit vector, when you take a dot product between the two unit vectors, if it is 0, then the angle between this coordinate exists. The x coordinate exists and the y coordinate exists. The angle between them are the angle between them is 90 degree. So similar to that, you can prove that the plane polar system is orthogonal. How do we prove that? You simply take a dot product between the unit vectors along the r and theta coordinate line. So along the r and theta coordinate line, you take a unit vector dot product r dot theta, r cap dot theta cap. So you know that r cap is this, and your theta cap is what we have just obtained, minus of sine theta I plus cos theta j. You take a dot product here, you will get 0. So from the dot product rule, you know that like if you take any dot product between two vectors, it's going to be a magnitude of the first vector, magnitude second vector, and cosine of the angle between them. And this quantity, as you see, it is 0, means cos theta is 0, because magnitude of this r cap and theta cap are unit vectors. So if they are unit vectors, magnitude of this is 1, magnitude of this is 1. So they are unit vectors. That means this 1 and 1. So go then if this r dot theta cap is 0, means the only possibility is that cos theta is 0. So cos theta is 0 only when theta is 90 degree. That means the angle between your r cap vector and theta cap vector is what is that? R cap vector and theta cap vector is 90. Right, angle between r cap and theta cap vector is 90. So I think you can also see that something like this. So let's say this is the origin. Let's say this is your r axis. Right, your r axis. R means it simply measures the distance of the point from the origin. So at any point here, if you take a tangent at this point will be straight line, means it will be pointing along this direction. So this will be your r cap direction. At this point, if you take a tangent, you are having a straight line. So tangent is also having the same direction as a straight line, and or the coordinate axis r cap. All right. But you know that this is your theta coordinate. So theta equal to 0 is here. When theta is 0, the point will be here. But as you increase theta, the point is tracing along this line. If you increase your theta further, the point will be moving along this direction. Right. As you increase your theta, the point is moving around. The point will move around. For a fixed value of r, if you increase theta, the point will, if you increase theta from 0 here, it will move along this and it will move around like this. Right, it will perform a circle. So as you can see, your theta coordinate is curve. Theta coordinate is curve. Theta coordinate line is curve. Well, your r coordinate line, r coordinate line, r coordinate line is straight line. Okay, your r coordinate line is straight line. It is simply a measure of the distance of the point from the origin. So you can move along this direction. It's a straight line, simply measures the distance of the point from the origin, right? But as you increase your theta value increasing means it will move for a fixed value of r. It will move your point from this to this, and then it will move around a circle as theta increases from 0 degree to 360 degree, right? So the theta coordinate line will be a curve. So what is the difference here? In a 2D Cartesian system, your x coordinate line is a straight line. Along this you have positive x-axis. Along this you have a negative x-axis. Along this you have a positive y-axis. The direction is defined by j cap. Along this you have a negative y-axis. Direction is defined by minus of j cap. So x-axis is a straight line. Y-axis is also a straight line. Now we are when we are into this plane polar system, not only that we have one coordinate line as a straight line, we are now encountering a coordinate system in which one of the coordinate line is a curve. It's no longer a straight line. Okay, one of the coordinate line is a curve. It's no longer a straight line. Theta coordinate line moves around a circle for a fixed value of r. So what is the theta cap here? At this particular point, theta cap will be tangent to this circle. So tangent to the circle will be pointing along something like this. This is your theta cap. Okay. So plane polar system is orthogonal. What does it mean? Orthogonality of plane polar system means that at this particular point, your r cap direction and theta cap direction is at 90 degree. Because when you take a dot product between r cap and theta cap, you are getting a 0 degree here. Okay. Now, if you increase your theta value like this, you are moving to this point. You are coming to this point. When you are coming to this point, your r axis is along this direction. This is along this direction. So if you take a tangent, this is your r coordinate axis. It's a straight line. If you take a tangent to this r coordinate axis, then divide the tangent with the magnitude, then you will get your unit vector r cap here. Okay. Unit vector r cap like this. So at this point, if you take a tangent along the theta coordinate axis, so theta coordinate axis is like a circle. It's moving around in a curvature or a circle. So you take a tangent at this point, then the tangent at this point will be pointing along this direction. Divide the tangent vector with the magnitude, then you get what is called theta cap, unit vector along the theta coordinate axis. So at this point, your theta cap is pointing along this direction. At this point, your r cap is pointing along this direction. But the orthogonality of this plane polar system means that